What we really wanted to achieve here is like, well, why make this really fast car that's crazy fast and everything? And I think there is something that's quite important to the future of sustainable energy, which is that we got to show that an electric car is the best car, hands down.
At an interesting time when the US plays catch-up with increasing tariffs while China leads the global EV market, recent patents tell of Tesla's upcoming propulsion system that would stop the competition once and for all. Strangely enough, this new system relies on SpaceX's old propulsion technologies that were never designed for EVs.
Maybe you can tell me why you initially wanted to work for Tesla.
I wanted to work for Tesla because of the innovation, right? Being on the forefront of pushing technologies forward and really trying to push the boundaries really fast.
So why take the risk of reviving an outdated system? And what makes Tesla so confident it would work? Join us as we explore the story behind the system, the stunning upgrades made, and how it could change everything. History of Tesla's propulsion systems. Every great invention has its humble beginnings, and today we'll take you back to 2003, the year when two famous engineers, Martin Eberhard and Mark Tappening, made a powerful prototype system in California that would later become the Tesla Roadster. Interestingly enough, the EV market was going through a very difficult time. GM's EV1 had been released in California and was hated so much that it got shut down barely 3 years after release. Ford's Ranger EV was pretty much dead on arrival and was only used in fleet programs. Toyota's RAV4 had a better range, but was only produced in smaller numbers due to how expensive it was, and manufacturing was riddled with delays. This was the failing industry that Tesla's founders wanted to dominate, and it seemed almost impossible to pull off on their own. But Tesla did this by rethinking how batteries could work on a practical level. Not only did the Tesla Roadster use lithium-ion cells instead of a single big lead-acid battery that easily ran out of power, but they also relied on battery packs containing almost 7,000 power cells wired together to give over 50 kilowatts of high-energy storage, sustained by liquid cooling over prolonged use. Each of these thousands of power cells was manufactured by Panasonic, a Japanese company that would later become one of Tesla's most important partners moving forward. Thanks to its help, Tesla was able to build and release the Roadster in 2008 to the surprise and cheer of the growing industry, as it was cheaper than any other EV on the market. But even with all the things it could do, the Tesla Roadster was plagued with many issues. For one, even though it was the most affordable and practical EV, it was still too expensive to make, and the charging system was very slow. With the money gotten from the Roadster's success, Tesla got to work on crafting a more affordable vehicle that could be produced in larger quantities while charging much faster than ever before. Coming out later on in 2012, the Model S was built with a better propulsion system and a lighter and more streamlined battery than the previous model. While the Roadster's battery was located on the rear end of the car, the Model S had its battery made flat and located under the floor of the vehicle to help with balance and space. The new propulsion system included an electric motor, inverter, and gearbox, all made by the company and built at the newly bought Fremont factory in California. The Model S became an instant success, making headlines and selling more units than the Tesla Roadster. But as usual, there were significant problems with the new machine. First, it was much larger than most cars at the time and also struggled to fit in most parking spaces in highly populated suburban regions. And even though it had a large size, the components inside were so tightly packed that battery overheating was always an issue. On top of that, now that all the things required to manufacture the EV were made in-house, Tesla struggled with supply, immediately leading to multiple production delays and the need to restructure their manufacturing systems. As they kept improving their propulsion system with software updates and newer designs, Tesla released the Model X SUV in 2015 and would later release the Model 3 in 2017 and the Model Y in 2020. And while each release came with better performance, with a longer range and smarter software, The Model 3 was perhaps the biggest seller of all the EVs sold at the time. Not only was it cheaper and most practical, but it also served as the entry point for most users into the now successful EV market. And it was at his time that most auto enthusiasts were now getting comfortable relying on EVs over traditional cars. Tesla had now achieved the impossible. EVs had now become mainstream, but it didn't take long for the cracks to show. Demand for the Model 3 was much higher than expected, so high that mass production quickly grew from a dream come true to a nightmare they would struggle to recover from for years. To make production faster and easier, they tried to rely on automation for all their manufacturing services. But of course, this only turned out to be a disaster that caused more delays and quality issues. Elon Musk later admitted that his machine that builds the machine initiative didn't work as the company intended and only made things too complicated. They had tried to automate too much too fast, and that only caused even more delays and quality issues. Elon and his team approached Panasonic once again to help with the situation, and the result of their new partnership was the Gigafactory in Nevada. But this too became another nightmare for Tesla, as they sought to build bigger batteries with more intricate automation systems than ever before. This caused multiple delays in ranking up the factories, leading to many disagreements between Tesla and Panasonic over production speed and quality control. It turned out that Elon's vision of a very large factory to solve all issues with production and supply was overly ambitious. Panasonic was on the verge of opting out from the agreement entirely, leading to Tesla making plans to learn how to build better batteries without relying on partners to do anything. This led to the stunning announcement of 2020, the 4680 battery cell, a larger and cheaper battery model far superior to what they had built with Panasonic just a few years before. This new cell would make cars cheaper and much better for the environment. And as we shall see, it was at this point when the need for a better propulsion system was clear. The upcoming propulsion system. Learning from their previous mistakes, Tesla built smaller factories in other places like Texas, Germany, and other places. They also started making battery components on their own, by partnering with other companies like they did with Panasonic, but by buying companies like Maxwell Technologies for dry electrode tools and Hybar Industries for battery manufacturing machines. But even with all these resources, making the 4680 battery pack was much trickier than they thought. It turned out that making the batteries that users were asking for was slow and ineffective, pushing Tesla to start considering other types of battery chemistry like lithium iron phosphate over the traditional lithium-ion system. During this time, they had been working on another propulsion unit called the Plaid powertrain. They first advertised it in the Model S Plaid in 2021 to solve all the problems Tesla had become known for. It would have 3 electric motors capable of going from 0 to 60 miles an hour in less than 2 seconds. It served as the fastest production car in the world, and each of the motors was smaller, more powerful, and used a rotor coated with durable carbon-based materials. But Elon Musk was doubtful this product would last long on the market, not because it was fragile, but because it was hard to build. This meant that if the Model S Plaid was going to be successful, it would have to be advertised as a high-performance luxury vehicle, which was far from what was intended at the very beginning. You see, Elon Musk and his team wanted the Plaid to be a more affordable version with better features than the first Model S, giving the perfect upgrade for many problems that plagued the car for years. So, as mind-blowing as the Model S Plaid was, it wasn't the dream machine that Elon Musk and his team had in mind. The goal was to create a simpler, more affordable machine that would bury the competition forever. But to do this properly, Tesla would have to be bold and aggressive with its approach. Tesla needed to focus more on building better materials and improving their magnet design along with the electronics controlling the motor. The first step they took was incorporating silicon carbide in their power electronics to reduce heat and energy loss in the inverter. The problem was that Tesla still couldn't do this on their own and had to rely on other firms like ST Microelectronics and ON Semiconductor to pull this off. It wouldn't be until 2023 when Tesla begins to fully design their chips for inverters and drive units to make their systems more efficient. They believed doing this by themselves would make things cheaper for their upcoming propulsion system. What they didn't realize was that making silicon carbide was much more expensive to scale. So to cut costs, they had to take it all back by completely changing the inverter layout they had designed and making a significant upgrade to the software. This was intended to bring manufacturing costs down while keeping performance high. Of course, knowing how big the changes were, many efforts were made to keep the entire project secret. But even in early 2024, the rumors were high everywhere, with many claiming to know anonymous sources hinting at a new system believed to be a new kind of engine. For this reason alone, most of these rumors were easily dismissed as fake, especially when it's well known at this point that EVs don't run on engines. It's what made them special in the first place, so claiming that Tesla had a new engine in the works sounded more like an oxymoron. But one aspect of these stories was something nobody could deny. Tesla was working on something revolutionary. The problem was discerning what was real and what was fake among the myriad of reports hinting at the new product. Interestingly enough, by late last year at their Gigafactory in Texas, various engineers had been testing a new kind of drive system that didn't rely on expensive rare earth magnets from China. They instead worked with companies like Novonix in Canada for battery testing and relied on lithium iron phosphate for their batteries. As you might expect, that decision made the drive system less powerful and efficient, but this is where it gets interesting. To get around the weakened system, after years of endless toil and research, Tesla was somehow able to develop new rotor materials with better magnet placements. It seemed every new problem forced a new invention, and behind the scenes, Tesla's AI and Dojo systems were now used for running simulations on battery chemistry, motor control, and basic design. And it wasn't until early May this year, during a surprise live stream from Tesla's new research lab near Austin, Texas, that Elon Musk confirmed that they were indeed working on a new drive system, but gave no images of what it would look like, just hints on how it would function with very limited information. So let's break it down one part at a time. How will it work? Based on the presentations given by Elon Musk, this new system would work much differently from the older electric motors and batteries. The tech billionaire hinted that the drive protocol would rely on a mix of solid-state battery chemistry, smart cooling, and a special motor design. So why is this a good thing? The answer lies in how batteries work. You see, a normal battery in electric cars today is made of liquid chemicals with 4 main parts. The positive side is called the cathode, the negative side is called the anode, and the liquid is called the electrolyte. The final part is a separator that keeps the two compartments from touching. Whenever an EV starts running, the lithium ions move from the anode to the cathode through the liquid to produce energy. When all the lithium ions have moved over, the battery runs out of energy, and the user would have to recharge it. With that said, all charging does is move the lithium ions back the other way, so the process can start all over again. It's a very practical way of storing and using energy. The problem, however, lies in the liquid electrolyte and how it reacts. Though it has made batteries less degradable and easily rechargeable, it also made cars more prone to explosions from minor hazards and overheating from fast supercharging. Why hasn't Tesla released the Dream Supercharger that fully charges our batteries in less than 5 minutes, even though the idea has been pitched many times for over a decade? The answer is primarily because of overheating, which shortens the battery's lifespan. You see, liquid electrolytes are very flammable and they heat up very easily under fast charging. It was for this reason that Tesla sought to build their first solid-state battery with the help of the two companies they bought for this sole purpose, Silion Incorporated and Maxwell Technologies. This new battery has no liquid electrolyte in the middle and relies on a solid layer that lets lithium ions move much faster during charging without heating the battery. This solid layer doesn't burn easily and still charges just as fast when it gets hot. Better yet, the battery is designed in such a way that can be packed tighter with much more energy in a much smaller space. It doesn't swell or leak like older batteries and can be shaped to fit inside the car's structure, so the ship car, in a way, becomes part of the battery. But as mind-boggling as it sounds, this comes with one big problem. While solid-state charging is faster, extracting power is a much different story. So, to get around this, the specialists at Tesla's lab in Texas added more sulfur to the cathode to make it more active. This lithium-sulfur mix stores more energy and is lighter than the more common ones from other companies. Knowing that sulfur breaks down after many charges, the team went a step further to coat it with undisclosed materials made by Hybar Systems to stop it from falling apart even after 3 years of prolonged use and thousands of charges. Now let's get to the good part, and that is the motor. As we know, electric motors usually work by relying on magnets and wires. When electricity flows through the wires, it creates a magnetic field that pushes against other magnets inside the motor to make it spin. The moving part is the rotor, and it relies on string and expensive magnets known to be very reliable and efficient, but also harmful to the environment. Elon reveals that the new rotor for the upcoming drive system would use a material made from carbon fiber and ceramics that have been tested and used in rocket engines from SpaceX. With this, the rotor would spin very fast without breaking or overheating. This leads us to the big question: how would this rotor work without magnets? During the live stream, Elon hinted at new method workers at the lab had been testing in recent weeks. This technique is called induction. This is the process of using electricity to create a moving magnetic field inside the rotor. This is where Tesla's old silicon carbide inverter chips come in, and if you recall, these materials handle more heat and switch faster than normal silicon. The chips are also part of the inverter that changes the direct current power into the alternating form that is needed by the motor. The inverter would be directly linked to the new AI that is inspired by Tesla's Dojo system, which was initially built for self-driving and automation. Now, Elon promises that it will be used to control motor speed, power delivery, and battery temperature on its own without input from the user. It runs based on results obtained from millions of simulations running round the clock at Tesla's data center in California. Thanks to these, the car would work at the best level without wasting energy from hazards. Interestingly enough, one of those dangers is overheating. So let's talk about it. Beyond the improvements made to the battery, Tesla went above and beyond to address the overheating problem by once again taking note of its sister company, SpaceX. As of today, many Tesla cars rely on an ethylene glycol-based fluid called G48, designed to regulate temperatures in almost every part of the car. But while it's been very effective in handling overheating, it also comes with bigger problems of its own. For one, though it works very well as a coolant, it absorbs heat very slowly under high stress. Also, G48 boils under very high performance, even though it is regulated by pressure. It has a viscosity that gets a lot thicker in cold weather. Ironically, it fails to manage overheating during cold climates, meaning that while the environment is close to freezing point, the car's internal system is almost at boiling point, even with advanced cooling. To bypass these shortcomings, Tesla is trying out a better liquid cooling system that utilizes a better substance called RP1. This liquid is a more refined form of kerosene that has been used in SpaceX's Merlin rocket engines with high thermal stability and energy density. Elon's idea is that since it's good enough to withstand the immense heat of rocket propulsion while being stable enough for lesser uses, then it's practical to try it out in upcoming Tesla vehicles. This works on a very practical level, even though the RP1 fuel isn't a coolant in the traditional sense. This now leads us to the final aspect of Tesla's upcoming propulsion system, the charging. So far, most chargers from Tesla send electricity from a walled unit or station directly into the car's battery. But all that is about to change. Tesla's new system relies on a whole different mechanism called pulse charging. To put it simply, it means the lower would be sent in short bursts instead of one steady flow of electricity to the battery. As strange as it sounds, this idea came from the workers at the Texas lab when they found out how effective it was in charging storage rings. By pulsing the power, the battery doesn't heat up as much and takes on much more energy faster. We know this because there are now charging stations that use pulse technology at supercharger sites in places like Nevada. The world is excited to get a glimpse at this new system developed by Elon Musk and his team. And until it makes its debut later this year, we'll have to wait and see what the company has in store for the industry. So, what do you think? Will Tesla dominate the EV industry with its upcoming propulsion system, or will the project crash and burn like most overblown ambitions? Let us know in the comments down below. If you enjoyed the video, please make sure you like, share, and subscribe. Also, click on the next video shown on your screen. You will enjoy it.